A car, we'll call it car 2, is traveling at a constant speed of 33 meters per second on a highway. At the instant this car passes an entrance ramp, another car, we'll call car number 1, enters the highway from the ramp. Car number 1 starts from rest and has a constant acceleration. What acceleration must car number 1 maintain so that the two cars meet for the first time at the next exit, which is 2.5 kilometers away? To solve this problem, we are led to the equation that the displacement, which we know, is equal to the original velocity of car number 1, which is 0, multiplied by the time of the story, which we don't know, plus 1/2 the acceleration of car number 1, which we don't know and is also the unknown that we're trying to find, multiplied by the time of the story squared. To find how long the story lasts, we are led to the equation that the velocity of the second car, which we know, is equal to the displacement, which we know, divided by the time of the story. Next, we solve this equation for time and substitute it into the first kinematics equation we wrote, after which we can solve for the unknown acceleration in terms of the given information, which is the displacement, the original velocity of car 1, which is equal to 0, and the velocity of car 2.
Let's now take a look at the motion graphs.
Car number 1, recall, starts from rest and accelerates constantly. So curve number 1 here is parabolic, and that's for car number 1. Curve number 2 represents car number 2, which is maintaining a constant velocity. Where these two graphs cross is where the two cars meet the second time. And that would be at a displacement of 2.5 kilometers. This graph here shows car number 2's constant velocity and car number 1's constant acceleration. This is the end of the story, TF, and recall that the area under a velocity time curve gives us a displacement, which should be equal to 2.5 kilometers for both cars. The area under the velocity time curve, which is shaded here, should be equal to the area under this rectangle. Can you see that that's so? This little section here of the right triangle, you see that that would fit perfectly into that space, which shows that the two areas are equal, which they should be. This graph here shows the acceleration of car number 1. Car number 2 has no acceleration.